Hello guys, you are welcome to Ojema YouTube channel. We have already solved the 2025 Neco practical on SWOT analysis. We have solved SWOT analysis. The answers, that is questions, we have already solved them. The exact question in the exam, the one they gave you, we have already solved them. Now we are into volumetric analysis, that is titration. Remember, what I'm solving now is the Neco 2025 chemistry practical. What I'm solving now, okay? So just follow the steps. I have already drawn my table. Look at my table here. Number one, the question one is you are asked A. Look at this thing. You must state this thing. Volume of pipette. You must state it. This question has what? 2 marks. This is your table. You must put your table in this order. This decimal place must be in 2 decimal place. Okay. At the end, a part of it is that calculate the average volume of acid used. This is the average volume of acid. Okay. The next thing you are asked is that you have question AII. Under question AII, you are asked to state the pH of solution A before titration, the pH of solution B before titration, and pH of solution at the end point. What are their pH? We now say one now, pH of solution A before titration is what? Is less than, because it's an acid, so it will be less than what? Is less than 7. Now go again. pH of solution B, because it's a base, so it will be more than what? 7 before titration is what? Is greater than 7. Then the next one is what? It says you state the pH of solution at the end point. What is the pH at the end point? pH is what? Equal to 7, because at that point now there is a neutralization. Okay, now we are done with that one. This is question A. This is what you are asked all about that question A. Question B now, BI. We have BI, BII. You are asked to calculate concentration of solution A in moles per dm³. Concentration of solution A in moles per dm³. Now you are asked to calculate concentration of solution A in moles per dm³, concentration of solution B in moles per dm³, concentration of solution B in grams per dm³, the percentage of solution B, and also why is it that sodium nitrate does not take part in the titration. Those are the things that you are asked. Okay, so now let's watch out as we proceed. Now we are asked to calculate concentration of solution what? A in moles per dm³. I told you that when you are calculating concentration in solution B or solution A, if the two things are given in moles per dm³, you use the two formula which you are going to use now. The first formula is molar concentration. I will write it in front. is equals to mass concentration over molar mass. Okay, now you see molar concentration, which this is what you are going to, which this is what you are asked. Concentration in moles per liquid is called molar concentration, while concentration in grams per liquid is called mass concentration. So molar concentration is equals to your mass concentration. They gave you 6.3 grams per dm cube. So here 6.3 divided by what's the molar mass? Your acid is what? HNO3. Okay, HNO3. So you see molar mass of this one, say 1 plus 14 plus, please do this one before you put it in your formula, plus 16 times 3. So at the end we have what? 6.3 divided by 63. So we have what? At the end we have 0.1 moles per dm cubed. That is your answer. Okay, that is your answer. Answer for BI. Okay, that's your answer for BI. Let us go to BII. Take note of that. Look at how you are asking, what you are asking here. Mass concentration all over what? Molar mass. This is a mass concentration. It's given in grams per dm cube. Divided by the molar mass of HNO3, because that is the acid that you use. Okay, let's flip through. Now, the next thing you are asked is what? Concentration of B in moles per dm cube. So we say that BII using formula. We say CAVA over CBVB is equals to NA all over what? NB. Now your CA is what? CA is what you have here. Look at your CA here. CA. Okay, CA is what? 0.1. So you say CA is equals to what? 0.1. VA is equals to, look at your VA here, look at it here, 26.00. So you have what? 26. The next one is what? CB is equals to, that is what you are looking for. So you put question mark. Okay. The next thing is what? VB. That is your volume of base is what? 25. The volume of pipette 25. The next thing is what? NA is equals to what? Remember, the equation of the reaction is what? The equation of the reaction is HNO3 plus N2CO3 give you what? Give you NaNO3 plus H2O plus CO2. So here we have what? 2 here. We have what? 2 here. Okay. So the mole ratio is what? 2:1. There is 2 in front of this acid, and there's 1. This compound, there's nothing here, so it's what? 1. So your Na here, which is your acid, is what? 2, and your Nb here is equals to what? This your Nb is what? 1. So put it in the formula. So you now say that CB is equals to, you make CB the surgery formula. So you have CAVA NB over VBNA. So you have CB is equals to, what is your CA? Look at your CA here. 0.1 times, what is your VA? Look at VA here. 26 times your NB. Look at your NB here. 1. Okay, 1 over VB. What is your VB? VB is what? 25 times 2. CB now equals to what? 2.5 divided by what? 50. CB now is equals to, what do you have? You have 0.052 moles. You must put this unit moles per what? DMQ. So at the end we have our CB as what? 0.052 moles per what? Per DMQ. Just take note of that, okay? The next thing, which is your BIII, you are asked to calculate concentration of B in grams per DMQ. Concentration. Look at what you are given in the question. Calculate concentration of Na2CO3 in grams per what? Per DMQ. Now, using the formula is mass concentration, because anytime you ask concentration in grams per DMQ is what? Mass concentration. So you say mass concentration is equals to molar concentration. I will abbreviate it, okay, times molar mass. Molar concentration times what? Molar mass. That is what mass. But you know that molar mass of Na2CO3 is equals to what? N here is what? 23 times, has 2 atoms, 2 plus carbon here is what? 12 plus oxygen here is what? 16 times 3. So at the end of it you have what? Multiply this one at the end of 106. Now say at the end, say concentration of Na2CO3 is equals to molar concentration of B. Look at molar concentration of B here. 0.052 times 106. Are you following? So what will be your answer? Your answer will be, if you multiply this one, will be equals to what? 5.5. Okay, 5.512 grams per what? DMQ, because you are asked to calculate this in grams per DMQ. So that is your answer. Are you following? Do you understand? Now you now proceed. The next question is, you are asked to calculate percentage of sodium in B. Percentage of sodium in B. What is the percentage of sodium in B? Remember, B contains 2 salts. What are the salts? They give you Na2. Let me put it here. This one is not part of the calculation. We have Na2CO3. The grams of is what? 5.5. Why NaNO3? The gram of it what? 2.5. So if you add the what, give you what? Give you 8. Now you are asked in the question they give you, say, let's just say IV. Okay, IV, that is BIV. They say they should calculate percentage of Na2CO3 in what? In B. B is a mixture of these 2 salts. Okay, they are now asking to calculate the percentage of this one in these 2 salts. If you mix these 2 salts, will give you what? That's what you are asked. And the formula you are going to use is what? It's a molar concentration. That is mass concentration. That is concentration in grams per DMQ. Concentration, okay, times 100 divided by the mixture, which is what? 8. You understand? The mixture of the 2. So what do you have here? We have 5.512 divided by what? Divided by 8 times 100. This 8 is the mixture of these two things. Okay. Why mass concentration is this one? Okay, that is to calculate your percentage. Now at the end you have what is equals to 68.8%. Do you understand? Then the next question, which is the last question, you are asked that why is this one sodium nitrate, why is it that this sodium nitrate does not take part in the reaction? Why is it that it is not used during the course of the reaction? Now, I earlier explained in my video that it is not used because it's a neutral salt. There is no way you can titrate acid against a neutral salt. You either titrate acid and base. That's why they call it acid-base titration. Acid-base titration, not acid-neutral titration. So that one is because of what? This salt is a neutral salt, while this one is a basic salt. Okay. So you say give reason why is it that this one is not used during the titration. So let me give you the reason, and that will be the end of that question. Now see now. You see NaNO3 did not take part not take part. Okay, not take part because of what? Because it is a neutral. It is a neutral salt form. It's a neutral salt form from strong acid and a strong base, and a strong base. So when strong acid and strong base react, they form what? A neutral salt, like HCl plus sodium hydroxide. They will give you NaCl. That is a neutral salt, sodium hydroxide. So we have come to the end of the practical solution, Neco solution 2025. So this is C. Have you seen it? That is our C. Have you seen? Take a look at this one. Have you seen the solving? That is a solving. That is what you are going to solve. And at the end, we have already solved our salt analysis. So just hurry now and go and wash. Look at this. The first part here is the first part. Okay, look at it here. All right, thank you for watching. Bye bye.